Hi, good afternoon, and welcome to Dealing with the Technical Debt webinar. Before we start, just a couple of remarks. This session is going to be recorded and posted on our website, so if somebody cannot join, they will be able to watch it later. Also, we have a Q&A session or section. If you have any questions, feel free to post them on the Q&A section. I will try to answer them at the end of the presentation. While I'm going to introduce myself, maybe you can provide a little bit of information about yourself. We have posted a poll with 3 simple questions in which we try to gather a little bit more information so we can maybe better fine-tune our webinars in the future. That being said, my name is Remus Pereni. I'm a software architect and CTO of TSS Yonder. I've been working in IT as a software developer professionally since 1996. I've been always in love with computers and programming, so basically my hobby for computers as far as I can remember. But Metro Yonder was actually my first company I worked for. And I started in 1996 as a Progress 4GL developer, and quickly changed to Java and then front-end development and so on. In 2000, I had to take a short break to do my army service, and also took the opportunity to start a company with a couple of friends, doing some exciting open source projects and so on. In 2005, I returned to Yonder, and I had a slight career as a project manager, delivery manager. And after figuring out that that's not the area that recharges my batteries, I quickly turned to the technical track and followed the tech lead and architect position. And since 2017, I also hold the position of CTO. I'm still involved on the technical side in the projects, although most of my time is spent on IT due diligences and software audits, which basically are activities that I enjoy a lot because are also the type of activities that allows me to gather as much information as I can, especially about the good and bad decisions that have been taken in projects that have quite some age under their belt. So I could really witness what those decisions were and what could be the impact of those decisions. And I would like to basically share some of my insights into this through this presentation. So basically what I'm going to talk about is what technical debt is, how technical debt is affecting your projects, how can you assess the impact of the technical debt, what kinds of technical debt we have, because one of the insights was basically that it's not one kind. We have different types of technical debt, and each type of technical debt has a different type of impact over your project. I'm going to talk about code debt, architectural debt, technology debt, and I'm going to touch a little bit testing debt. But basically, I would encourage you to subscribe to my colleague Kodruca track on testing. Also knowledge debt, and we also have a special track prepared for you with our colleague about UX UI debt. That being said, I do expect the session to be slightly technical. So if you have questions or unclarities, just feel free to post them in the Q&A session. I will try to clarify them as best I can. So what's technical debt? It's a funny term because although people would think about personal debt, and the funny part about personal debt is that in essence, you cannot have it without knowing about it. Technical debt is more like a national public debt. So something you don't really necessarily did, but you're expected in some form or shape to pay at some point. From my perspective, basically technical debt is any kind of misalignment between your current architecture or technology stack and the desired or expected technology or architectural stack. So every decision you did not make or did not implement that would have benefited you from a technical perspective today, it adds to the technical debt. The best way to explain technical debt to non-technical people is this. Most would imagine that in terms of development, code organization, implementation, things would look like the picture on the left. Everything is ordered nicely, put into sections. Basically, the more technical depth you have, the more your project or your source code looks like on the image on the right. And that is basically the consequence of many, many small but significant decisions that have or not have been taken during the many years of project development that in the end resulted with imperfect implementation, more complex implementation, more complex than required organization of code, improper use of technology, and so on. And the result of that is, as you can imagine, whenever you're trying to find something or get out something out of your closet, basically everything falls out. You have a hard problem or hard time trying to figure out where to look for. You have a hard time figuring out how to put that back, and so on. So I found the closet example as the perfect example to visualize the impact it has on your development team, but also on the developers that are required to work day in, day out with that type of closet. And how you get there, it's, I guess, kind of a simple process in which you just rush after functionality, promises to customers, and basically push on the functionality side with no time to do the refactorings or to correct the architecture or to correct the technical implications of whatever is required. So basically, you just pile up wrong decisions that basically are never corrected. And these will tend to add up. After 10, 20 years of development, this can add up quite nicely. Unfortunately, we only take parts of the recommendation and best practices, because Agile as an approach to software development, it's lean in the sense that allows you to really focus on changing course as often as required. But in essence, Agile also comes with the concept of refactoring. So making sure that the technical implementation beyond or beneath your functional implementation, it's also constantly corrected or adjusted to reflect the new realities. And most of the time, we are in such a rush that we often neglect or ignore to correct those areas. And the effect of this technical debt, it's reflected on the internal quality of the product. Now, in essence, if you're looking at the quality of a product, we have an external quality, which is the quality perceived by the stakeholders, the users. And we have an internal quality, which is basically the quality of the software as the way it has been built and constructed. Now, having a good internal quality doesn't guarantee that you have an external quality. Basically, you can have the wrong type of functionalities implemented, or you can have the wrong type of user experience implemented. But vice versa, having a poor internal quality, it's almost always a guarantee of having a poor external quality. Because basically the results of internal quality is missed deadlines, is unstable or immature applications. It's application that crashes frequently, applications that are slow, applications that are not really designed or built according to the new realities your customers are expecting. Also, a good article and good insights into the difference or the impact a good or a low internal quality has on a product is described by Martin Fowler in the article I mentioned here. And Martin Fowler, I consider as a very important person these days, besides providing a number of books on enterprise patterns, he also is the provider of the book on refactoring. So basically what Martin Fowler says is that on long term, especially on bigger projects, higher internal quality always leads to being able to rapidly and more cheaply deliver functionality. And the turning point is basically very soon after you start the development. So the implication of that is that basically you can only afford having a poor internal quality if you're working on a proof of concept, which by definition is designed to be thrown away, or you're working on an experiment or an MVP that is there just to validate an idea. If you're working on a product, a core product or an add-on, it's always better and cheaper to focus on having a good internal quality, because on long term, it is able to deliver better than otherwise. And the impact of that is at some point, you will just work with the parachutes on. So you will be constantly kept back by difficult code to analyze, to understand, by unreliable code, by being unable to run your application in the right environment or with the right security. The big problem is that you're not really able to assess that, because every story that you're implementing in your sprint is different. It's very difficult to track the loss of velocity as a way that would reflect, for instance, the technical debt. So although we have all kinds of tools and tooling, and you will see at the end of the presentation also some books that would teach you how to look as a forensic detective at your application from a perspective of figuring out where technical debt lurks and what's the impact of that. It's very difficult to quantify in a KPI unless you're providing some kind of semantic while you're doing the implementation. So unless somebody is actually labeling commits as this is rework, this is refactoring, this is something that needs to be redone because otherwise it affects the quality, you will not be able to figure out the cost and the implication of the technical debt. From my perspective, the best way I found to be able to analyze the impact of technical debt is by looking at the ISO 25010 way to assess the product quality model. This is also the type of model that we are using to do architectural assessments in the project. So basically, we are taking some of the verticals like maintainability, compatibility, portability, reliability, and based on the quality attributes that are used to make the assessment of those areas, we can determine the type of technical debt or the type of debt, what kind of impact will I have on which areas. As an example, for instance, these are some of the results of assessments done in the past. And basically, the assessment has a general score, like a star, 5-star notation that erases or presents the quality. But also it has a break of that score based on specific characteristics like reliability, maintainability, and so on. Basically, what you see here, it's 3 different products. On the left, with a poor rating, is basically a legacy product, almost 30 years old, that never had focus on quality, and basically had all kinds of problems that were never addressed. So in the end, it fares quite poorly, both from a maintainability perspective, as a reliability perspective, also from a security perspective, portability. So basically, if you are not paying attention to technical debt, in 10, 5, 15, 20 years, basically all areas of your applications are going to be impacted in a way that might be very difficult to correct afterwards. In the middle, basically what you're seeing, it's a rewrite. So a large enterprise application freshly rewritten after an effort of 2 to 3 years. And although they did not have a focus on quality, you could see that in essence of a new implementation, it looks way better than a legacy application. But still, if there is no focus on minimizing technical debt, it's still relatively low in terms of quality. But also on the right, if you're looking at the application size, basically it's a smaller application. It's a new greenfield implementation of an application that has been written by 2 developers, so it's fairly small. So what happens is that in a smaller project, especially if you have right seniority, it's kind of easy to have a good internal quality. The lesson here is that as long as your project stays small, the impact of internal quality, it's easier to control and easier to keep in check. But the larger your application grows, and the more it is developed upon, the less it's going to be maintainable unless you pay important focus on it. So, as I mentioned, we have multiple types of technical debt, and I will go through most of them, focusing especially on the code architecture, technology, and a little bit on that, knowledge debt. I will have colleagues discussing more about UX and testing in the following sessions. How many of you are familiar with this picture from Clean Code, the book of Uncle Bob's? Basically, code is difficult to comprehend and to understand. The difference between good code and bad code is still in the number of what the fucks per minute. So in essence, although a compiler is able to perfectly understand your code, that's not the goal or the purpose of the developer. The purpose should be that basically another developer is able to understand the code. So writing code for humans is basically the challenging part when dealing with code debt. Code debt is basically about complexity. Many managers expect that basically developers will write new and fresh code all the time. But the reality is that actually the new code that has been written is just a small fraction of the whole activities. Basically, a larger portion of your time is spent in actually reading and understanding code, which means that actually the way the code is structured and written has way more impact on the maintainability part as expected. And the degradation in maintainability, as in an analytics done by SIG, Software Improvement Group, is non-linear. So basically, at some point, it will be a kind of fall off the cliff event. So at some point, it will be very difficult to maintain the code base if you're not following some basic rules. And the impact of code debt, it's especially on things like analyzability, modifiability, and testability. So basically, when we are talking about code debt, we are talking about things like cyclomatic complexity, number of decisions that have been taken in a method or in a function. The more these decisions, the difficult that function is to understand or to comprehend. Also, for instance, the more decisions have been taken in a method or a function, as the more the cyclomatic complexity is in that method, the more difficult it becomes to be testing it. Basically, if you have 4 ways or 4 decision points in your method, it means that you need to have at least 16 unit tests to be able to test each possible execution scenario. So making sure that you're keeping your code clean, small, easy to understand for a human being, not a machine, it means that basically you're keeping your analyzability, modifiability, testability, and in essence, your maintainability in check. I think SIG did the best job in trying to come up with the minimal number of rules or things that you can do to make sure that you're keeping your code debt into check. Things like limit the number of lines in a method to maybe 15 lines. make sure that you're not having more than 4 decisions or branching points per method. Limit the number of parameters to a method to 4. Prevent duplicated code blocks. And in general, keep things down as much as possible, because shorter, smaller methods are both easier to test, easier to comprehend, easier to reuse. As a developer, my only recommendation is don't ask permission to deal with code debt. Basically, it's very easy to fix code debt, especially it's very easy to write correctly the code debt. And it's relatively easy to fix code debt. So just do it right, because the impact it has on maintainability and on quality is rather high. Now, what you do when you basically have a legacy application in which did not have the luxury to go first time right with the implementation is basically try to focus on things that have an impact. As George Orwell put it, all animals are equal, but some animals are more equal than others. What that implies is that basically you have to find the intersection between the areas of your application that changes frequently and has the most depth. What happens is that if your application has depth, but it's in an area that doesn't change at all or often, basically that depth is there, but has zero impact on you. What has impact on you is areas that are unstable in the application. And most of the time they're unstable because of shifting requirements, changes in requirements, or because there is fault implementation in place. So if you find yourself in a legacy application with a lot of code base and also with a lot of code debt, the best way to approach that is to try to find what is the intersection between high complexity and high change rate, and try to focus on addressing those first, because those will be probably the ones that will have the most impact, the biggest bang for your buck. This is, for instance, analytics done on Cyclomatic on a project. It's not one of our projects, unfortunately, we cannot share that with you. But basically what you see here, every small dot, it's a class, or and you see a color coding of cyclomatic complexity. So the number of decisions are being taken in a special method. And the redder square is, the more complex it is. So as you see, and this is the, let's say, fortunate traditional solution, you see that there are areas that has more complexity than others. So trying to address all would be nice, but basically it would be kind of a waste of good resources. So trying to find which are the areas which are red, and also which are the areas that change frequently. So you need to touch day in, day out. So a reduction in complexity in that area will have the biggest impact on the maintainability for your time. And the way you can easily track, for instance, which are the most frequently changed, you have tools like Git Extras, which will provide you with statistics about most changed files. So if you run any kind of static analysis tool that is able to provide cyclomatic complexity, like SonarQube, using some tools like this that would allow you to see how many commits, what were the hot areas in your source code, would allow you to focus on the intersection that would give you the best impact on managing code debt. So again, in general, as a general rules, to go fast, you need to go well. The only way to actually progress is to make sure that your application is easy to understand, easy to change for everybody. And that's to have the internal quality built there. And also the Boy Scout rule. Whenever you're touching something in your code base, make sure that you leave it in a better shape than you entered. Also, it's important to have things like coding standards defined. So make sure that everybody is aligned in what it means to have good, understandable code. Have peer review, but peer review is not there to check syntax and check complexity. You can have tooling for that. So basically, you can use quality gates, PMD, Checkstyle, SonarQube, GSLint to make sure that you're keeping the complexity low and your code understandable. So for code depth, rely on tooling rather on human intervention, because tooling is able to do just as good as a job as humans in this perspective. Keep the humans for the rest of the depth, which are more difficult to deal with the tooling. The second is architectural depth. Here is basically a misalignment between an architectural style of your product and the expectations from reliability, from a scalability perspective of your project. And the biggest impact it has, it's on things like recoverability, fault tolerance, availability, and even maturity. So architectural depth, unfortunately, has a huge impact on the reliability of your software. While code depth has an impact on your developers and the ability of your developers to produce or to progress, it also has its true on quality. Architectural depth has direct impact on your customers in terms of cost of scaling the solution and the general maturity of the solution. Unfortunately, it also impacts maintainability in areas like reusability, modularity, and also testability. If you did not do your decoupling correct, if you did not construct your layering correctly, basically you end up with a typical kind of big ball of mud in which everything is tied together to everything. So whenever you're doing a small change in your application, it ends up having a huge impact because basically that change affects way more than it should have been affected. And for instance, this is what you're seeing in tooling like ndepend when you're doing kind of a matrix of dependencies. Basically, you see modules being used by a lot of other modules. And the result of that is whenever there is a change, for instance, in one of the modules that has a green line everywhere, it impacts a lot of other modules. The implication of that is any kind of small little change will ripple to your large code base. And if that large code base is untestable, untested, or is not tested properly before production, will result in a huge problem. It's also the typical source of estimation accuracy problems. Because honestly, tooling is able to provide you this type of metrics, but for the developers that participate in the sprint planning, most of these dependencies are not in their head when they're doing the estimation. And the impact of that is basically you're massively underestimating the impact and the effort required to do any kind of change in your application. Also, similarly, you have things like instability, which is basically a way an application is constructed in such a way that your decoupling component between them and also making sure that you have things like cohesion implemented correctly. So whenever, again, you're changing something that doesn't ripple to your own application, your change is encapsulated only where it has impact, direct impact. In this particular case, what we are seeing is that a lot of application, it's built in an unstable way. Unstable way, it means that basically there are no interfaces, everything is implemented finally, and basically that implies that whenever you're doing any change, that will ripple again through all the other implementations that basically rely on that functionality and such. So for instance, you have three zones here. Basically, zone of pain is the area in which all the others are basically using. And if the instability is high, so basically you're not really abstracting away your implementation, you're not layering architecturally correctly, it will have a huge impact over both maintainability, but also reliability and effort. It's also the typical zone of pain when doing upgrades. Whenever you're ignoring or neglecting, and we will talk about this and the technology depth section, a library, not isolating, not decoupling the layering correctly will imply that whenever you need to make a major change between a major version of your dependency, a library that you depend on, will have more effort required and more impact than you would wish for. So in essence, how you deal with architectural debt, unfortunately, it's not very easy. Usually, it's very difficult to refactor architectural debt. But as a principle, make sure you have some core ideas, things like solid, very well understood and agreed upon in your team. Things like high cohesion, low coupling, having something like a software architecture document. It doesn't have to be something very laborious, but have something that kickstarts any developer into understanding how your solution is supposed to work, what are the cross-cutting concerns, what are the way the application is being deployed. Having some kind of a tooling like NDPen, JArchitect, CodeMac, CodeScene deployed, and doing periodical architecture reviews just to make sure you understand, because these things unfortunately are hidden. They are not really visible unless you're looking for them. You can feel the impact. It's like boiling a frog. Basically, you can feel the impact. You can actually guess the impact because you cannot feel it on day by day. But basically, if you're looking backwards at the velocity you had maybe 2 or 3 years ago, you would definitely feel that your velocity is not there where it used to be. So making sure you have all these core practices very well understood by your team, and having periodic architecture assessments or review to make sure you understand where you're currently situated and what is the desired state, and make sure you take measures by either taking or allocating a percentage of your sprint to focus on technical issues. And I've seen that anywhere between 15 to 30% of the sprint allocated to deal with technical issues. But I've also seen approaches in which basically you have every 5th sprint, for instance, allocated on dealing with technical matters. So make sure you're allocating resources on dealing with technical matters is very, very important. Also, this is the part in which basically peer review really matters. If there is any kind of code review, a code review should especially focus on architectural debt, making sure that every new implementation or every change also corrects something from the expected architecture. And also, an important fact that I witnessed in many of the legacy modernizations or legacy projects is that basically refactorings or modernizations are never carried out completely. So you can always see the typical types of architectures that have been there from the beginning of the project. And that really adds complexity. And it also in terms of implementation, but also in terms of mental models, a developer would need to keep in hand when actually dealing with the application, because you will have all these traces of all the architectural styles that were really in fashion 5, 10, 15, 20, 30 years ago. So whenever you're introducing any kind of architectural change, make sure you're planning, and it's not a short-term plan, it's a long-term plan, but make sure you're planning to basically deprecate away legacy architectures and turn all the new architectures basically complete. As in general, just make sure you have a good plan in place to avoid or eliminate architectural debt, because the impact of it will be large, both in terms of reliability of your solution, but also in terms of maintainability and in terms of being able to keep it running on a longer period of time. So again, the impact is not going to be there for 1 or 2 years. The impact is going to be there after 5 or 10 or 15 or 20 years. And it's going to affect majorly a potential decision whether you can extend the lifecycle of your product, or you basically have nothing to do with it. Your only solution is to do a rewrite of it. The other type of debt that's kind of ugly and has a large impact is technology debt. And basically, technology debt is the fact that the underlying libraries, components, or platforms that you're using are not always kept up to date. Unfortunately, this has also a very nasty impact. It doesn't have on short term, but it definitely has one on long term on things like compatibility, being able to interoperate with other solutions, being able to host your solution with other solutions becomes problematic as you ignore your underlying dependencies. And we are talking here about database version dependencies, not keeping update your use database version or your specific libraries, but also things like not updating your operating system, not updating your platform to the latest operating system. And in the end, turning into a huge security nightmare, security problem, or interoperability nightmare. The better is you can prepare for that, because basically, if you do that in time, you will never be put in the situation in which you will need to take major decisions regarding your platform overnight, because usually the impact of this type of decision is large in terms of effort and cost. But it also affects things like instability and adaptability. Sorry, there's a typo in there. So basically, if you are not careful with the technology debt, you will find yourself either out of support or in a huge mess in terms of security or platform. And again, it could be as simple as updating a Spring library, but it can get as complex as updating from AngularJS to Angular, or basically upgrading from any kind of different, like Flash or Silverlight, for instance, in time, before it actually gets unsupported. Unfortunately, the bigger the problem, the more difficult it is to solve. So basically, if you look at small dependencies, core libraries, minor versions, having in your teams just a very good practice of whenever you're starting a new sprint, making sure you're updating all the core libraries and dependencies to the latest minor version that's supported. So you're gradually addressing security fixes and minor fixes in your dependencies with probably the lowest impact you have. But also, in fact, by preparing on larger upgrades, like from versions of Angular, like versions of database in time, when you're still in control, and be able to do that gradually. Either by allocating a proportion of your sprint time, or by having a dedicated sprint for the technical issues. Also, in general, it has to do a lot with architecture. If you're not making sure that your application core is well isolated for third-party dependencies, you will later find yourself in a situation in which whenever there is an unsupported platform, an unsupported library, or a major backward incompatible upgrade in your library, you would not find yourself in the situation in which you actually have to touch the whole code base, turning into a rewrite nightmare. So many young developers have the tendency to use as many third-party products as possible, everything that's in fashion at that point. This also creates a huge risk of creating this dependency to those third-party products that will ripple at some point through your own source code, turning any kind of upgrade into a major problem. Again, I'm not going to touch very much of the testing depth. Basically, what I've seen here is basically two scenarios. One is that there is not sufficient tests for your application. And the best way to deal with this is exactly like with the code depth. Use analytics to figure out which is the hotspot for your users. So there is always kind of a Pareto, 80% of your users use 20% of your application. Figure out what that 20% is and make sure that that is thoroughly tested. Also, have the right type of testing. So if you're having any kind of rule engine that does calculation, make sure that that part that's critical it's thoroughly tested, so you're able to do, whenever you're having major changes in there, do proper testing in there. The other extreme is actually having too many tests. I've seen situations in which there is quite a high coverage of test automation into your application. The problem is you need to plan for having the right Q&A resources to be able to maintain those tests. So what happens is the Q&A team is always under capacity to be able to manage those tests. And at some point, there will be a drift in the functional implementation or corrections in the functionality side, and the maintenance done on the test that would prove that functionality. And that drift, unfortunately, always ends up with tests being thrown away because they no longer reflect the reality, and nobody has the resources to fix them. So again, make sure your tests are modular, and make sure that you're testing the critical parts of your application regardless of what happens, and then the rest of the application as a nice to have if you have the resources. Another area I just quickly touch upon is knowledge depth. Basically what happens is you have either a high churn in your developers, so a lot of developers leaving your team together with the knowledge, but also in case you have a small team and basically each developer has kind of the area of expertise that they are working on. The result of that is whenever something happens to any of those developers, they are leaving or they get sick, you will have huge black holes in your application that will become basically too scary for the rest of developers to touch because they don't understand it, but also because they don't own it. The easiest approach to this is just identify those black holes, either technical, architectural, but also functional, and make sure that you have small knowledge transfer sessions between your developers team that are also recorded. And also make sure that you are categorizing those records. So having one large session of records will become kind of problematic in finding out resources later. But if you're planning focused sessions on specific topics and you're recording and cataloging those sessions, there will be a huge gold mine later on when there will be a problem with resources on that project. Just as to finish, a couple of books I would recommend. You have 2 books that are very good on the code depth side. So basically, the best practices for breaking your application into smaller parts, more maintainable parts. We have a Java edition, you have a C# edition. Sorry for the folks with the 4JL legacy system, there are no editions for everyone. But these are very good books on understanding and writing maintainable software. And also, I can highly recommend 2 books from Adam Thornhill. He's working a lot on trying to find innovative ways to get to surface, especially the architectural depth, the technology depth, the bad behaviors in your developers and bottlenecks. And he has some quite mind-boggling ways to kind of surface that. So that being said, by the way, if you have any questions or if we can help you with either an architectural assessment or any kind of architectural things, just let us know. Otherwise, let's look at the questions. By the way, yes, before I forget, so just another pool as we go through the question, maybe to try to figure out now that you have a better understanding on the type of debts that we have, which are the ones that you think will affect you the most. So let's go through the question list. In case that your technology is old and needs to be replaced, how do you deal with developers that are not eager to adapt and learn new technologies? That's a good one. Well, I'm not sure you can force anybody to really do something they don't want. Uh, uh, Basically, it's difficult. I think trying to reason would be one way to approach it, but also try to have some kind of metrics in place, some kind of case studies in place, just to showcase what the impact of not changing things would be on the product, in short or medium or long term. Unfortunately, if your whole team is like this, probably we'll need to take some more drastic measures. Maybe trying to add some new blood into your team, but also making sure that you have the right chemistry in there, because you don't want an internal war between team members. So I'm afraid I don't think I have a good answer for that. Just try to make sure you're showcasing what the impact of that decision will be on the product. And in case nobody is interested in adjusting, have the product manager take the right decision for the product. Another question: how do you talk with non-technical decision makers about technical debt when they are in control of your budget? That's a tough subject. Honestly, everybody understands technical debt is important and would need to do something about it, but everybody kind of drops it as the first sign a customer has any kind of troubles functionality-wise and so on. So unfortunately, addressing technical debt is usually between the first thing that gets dropped in real life. And the only way I found it plausible to address that is to try to put some kind of a metric on top of it. As I mentioned, it's very difficult to get that metric out of the box without adding some kind of semantics in there. You can have changes in your code base because there are changes in functionality. So just tracking changes in your application will not be a good indicator of rework. So trying to showcase that if you neglect or ignore basically to fix or correct the architecture, there is an implication of that. So have kind of a decision tree, have kind of an impact analysis done, have kind of the retrospectives on what went wrong and the cause for what went wrong, and make sure that basically you showcase that to managers. Everybody understands number. Lost productivity, it's probably something that people will get sensitive about. So make sure at the development side, you're trying to surface in metrics, in time lost, which can be derived then, a cost can be derived upon and so on the impact of that. Which tools do I use for doing the assessment? So basically, again, depending on the platform, because not everything works with everything, there is a part that is automated using things like JArchitect and NDepend to figure out the dependencies, to figure out the complexity, psychometric complexity, to figure out whatever the layering is, it's well created and so on. But unfortunately, a lot is based on manual analysis as well. The architectural parts are very difficult to be comprehended by tooling. So we really need to have the right type of people with the right experience in that. And again, I've been lucky enough to do this type of assessments for quite a number of years, and also to be involved in the M&A IT due diligence process, in which I can get a very good understanding of a lifespan of a project. The problem with architecture is that, in general, decisions will not be seen tomorrow. An architectural decision, the impact of an architectural decision will be probably felt in months, if not years. Many times the architect that actually made the decision will no longer be part of the team. So it's very difficult to assess decision and impact of those decisions over a long span of a project. So that's why bring somebody who has the experience, and especially if you're working in a group of companies, like for instance TSSs, just look at the others, try to learn from their experience, try to learn from other companies and other products. Okay. How much time do we need to factor in for refactoring? I would say, ideally, you would fix things. A developer would want to fix a product to be in the perfect condition, and that doesn't make sense financially. So from this perspective, having a lean approach is much more important. Figuring out the intersection of things that impact you and figuring out the architectural decisions that impact you is important, and try to address as much time as you require to factor them in. Basically, you can use time box. Again, I've seen in M&A processes everything from having between 15 to 30% of the time of a sprint for addressing this type of technical debt or refactoring issues. But also, I've seen approaches in which you have one technical sprint. Every fifth sprint, for instance, it's fully dedicated for technical aspects. Now, this speaking about things like architectural or technology debt. If we are speaking about code debt, basically, if you need to touch a piece of a functionality and that functionality doesn't have unit tests, it's too complex, I would say make sure you're planning for it in your sprint. So basically, you refactor it properly. So again, Boy Scout rule. Make sure whenever you're touching something, you're leaving it in a better place or a better state than when you enter it. So in essence, as much time as needed for the code debt, because that is usually more simple and the impact of that is it's less. But you need some kind of focus, and that's where you need buy-in from stakeholders, product manager, product owner, into having the technical stories in the sprint. And basically having a time box approach would work as long as you're approaching it in a lean way. So making sure you're dealing with those things that have an impact on you. So basically the impact is less and less. Which is more pleasant, one sprint of refactoring every sprint or time box during the sprint? I would say both works. There are certain activities for which you need more time. So for instance, by having a dedicated technical sprint would allow you to address bigger issues, like maybe in case you need to refactor the authentication authorization module, and that requires a bigger effort. Having just a small portion of your sprint allocated to this can limit a little bit the size of the things that you can take in a sprint. And that, in essence, can also create additional complexity, because by not being able to address things properly at once, you need to maybe sometimes introduce complexity to be able to break that apart into multiple approaches and deal with them in multiple sprints. The truth is, you can also have punctual things that you can measurable. You can have some measurable impact in terms of time spent, in terms of number of bugs, and in terms of scalability problems. Maybe you can also try to plan special technical stories in the sprint with the product owner agreement. Okay. Yeah, I'm going to share the slides. They will be made available, as mentioned.
Hi, Remus. Sorry for interrupting. There are 3 more answers or questions coming in the open section. The dismissed section, I've completely discussed with the panelists, with the attendees, but you have 3 more questions in the open section for you.
Okay, so basically, yes, thank you, Monique, for reminding that. How should you tackle the black hole of knowledge debt as a software developers? Who has to cover it and knowledge source is not available? Well, if it's not available, then it's not available. What I've seen being done is that maybe you can reach out for some old developers or old product owners who still had the knowledge or have been involved in that. I found that many of them are still willing to go through a remote session in which they explain some of the decisions or some of the factors that were used when the decision has been taken. Also, maybe you can involve your company into providing some kind of a paid session with those guys. If that is not possible because the people is no longer available, I'm afraid there is no easy answer to that. So unfortunately, reverse engineering is the only way you can do it. And that's extremely painful and extremely risky because basically what I've seen is that even the guys who have broadened the functionality, they pretty much forgot many of the things that have been in their 15 or 20 years when specific decisions have been made. So knowledge fades away, and if you're not able to track that or to capture that in time, it will be lost forever. And once you lost it, basically it takes a lot of energy and time to regain it. For instance, we've seen like almost 6 months being required to be able to transfer from scratch knowledge towards a new team of developers. So the effort required in making sure that you have this information available in retrospective can be quite high. So it's better if you do it while you have it. How should you tackle the black hole? Okay. Oh, sorry. Another question. Which is better, opinionated software where you have a way of doing things, or unopinionated where you have to make more decisions? I would say it depends. Both have advantages and disadvantages. For instance, in case of opinionated software, one perfect example, it's Angular. And I would say opinionated software, as long as it works along your way you want to develop software, it helps you. So it's a trade-off you make in which you trade off dependency on the third-party product to productivity. Now, of course, this trade-off is going to bite you later because at some point you will always have to pay the debt whenever that framework is going to mature. So whenever, for instance, Angular switched from AngularJS to Angular, there was quite a steep change that required quite a lot of rewrite. Same is, for instance, with low-code software, or in the old time, it used to be the 4GL platform. Again, you're traded a dependency for a tooling and maybe an correct at that point opinion on how architecture should look for productivity. And the productivity you gain, it's good, and probably it helped. But then you might be able to be in the situation, you might be in the situation in which you will have to pay for that debt 10, 15, 20 years later. For instance, almost all these 4GL platforms in 15 or 20 years will end up having with huge increases in license base, basically making your application less and less feasible, for instance. So again, make sure you're aware of this trade-off and make sure you're having the right decisions. From M&A process, what I've witnessed is that in general, systems that have been built on open platforms, so systems that have been built on C, C++, Java, Python, PHP, tend to age better. So you will find that those systems 20 or 30 years later, maybe still having technical debt, but being in a better position than the closed source alternatives. And maybe a last question. Technical debt computed by SonarCube is quite simplist, computed based on time of fixed issues found by static analysis. Do you know other ways to compute technical debt? So what I've seen done is do an architectural assessment. So using kind of the same approach, we are using the approach Software Improvement Group is doing. So Software Improvement Group has a number of papers published on how they assess the maintainability, the security, the reliability of an application. So trying to have that architectural assessment periodically, and you can do it with your internal team, or you can do it with an external team. We can help you with that, by the way. But making sure that you have a good understanding whether your technical debt is increasing or is decreasing. What I have seen, for instance, one of the best cases that was dealt with is basically they said that they want to achieve a 4-star internal quality in a yearly architecture review. So they did an architecture review every year. There were some findings based on that review, and those findings were planned in the sprints and addressed. So basically they were constantly working on first attaining those 4 stars and then maintaining those 4 stars. Do you think that trying to find a TD metrics based on all metrics such as MVC, cohesion, and coupling is realistic? I think it helps. Whenever you're calculating, for instance, things like maintainability, reusability, it does take account of things like cohesion. One funny story, for instance, about cohesion is that one of the recommended approach on rewriting or modernizing application is doing it progressively, while maybe integrating at the database level. So you are able to produce a new version of your application gradually, while still being integrated with the old application, so users are able to work with both. And what happens is that many times the model, the informational model of the old application will taint the new model of the new application. And the way it taints is by altering the cohesion, because mostly the legacy application had kind of a relationship of one-to-one between screen and database field. So if you're doing the integration at your database level, what happens, your new entities, unless you're doing a proper domain-driven design anti-corruption layer between the two, which you should, by the way, the way your old model works, it's basically influencing your new entities, and the new entities basically will have a poor cohesion. And that poor cohesion, guess what, is going to be rippling through the whole application. So having metrics like cohesion, coupling is important, but I don't think they tell the whole story. So I would say, yes, you should rely on them, but having something on top of that to make an assessment is probably more important. I guess we kind of run out of time. Yes, 2 minutes over. So thank you very much for your participation, and thank you very much for the question and the answer to the poll. Again, please don't forget about my colleagues' presentation on UI UX depth by Liviu, and on lessons learned on the Q&A from Kudruca. Also, we are preparing some other sessions following this, so stay tuned. Thank you very much for your time and attention. And if we can help you in any way through an architectural assessment, M&A, IT due diligence process, just let us know. Thank you.